Alright, so I thought I'd show a little deeper some of the shit that's happening here. Um, so I've noted before in the last video that something like this, like 5 plus 7, it's really, there isn't, plus is not an operation there. Addition is not an operation that's occurring there. What's really occurring there is we have a list. We have a positive 5 and we have a positive 7. And when we walk through that list, we end up at, what is that, 12? Sure, let's pretend I can do mental math right now. And that's 12. Okay. Now, we can break this down a little bit. Because what do these things mean? Okay. So, positive 5, what this means is move 5 steps to the right. Positive 7 means move 7 steps to the right. So, positive x means move x steps to the right. Okay. Now, say we've got something like, I don't know, 8 minus 3. Right. This can be arranged in a couple different ways, because, and we can see that the way that I framed it above is correct. So, if we rearrange this, right, what over here looks like a subtraction operation just becomes the sign, the unit of the 3. It's integral. It's a component of that vector, 3. Right? 3 is the scalar magnitude of the vector. Negative is the unit of the vector. And that 8 that is unmarked over here, it actually does have a unit. It's just our standard orthography doesn't mark it, right? So we get this, well, here, wait. I was going to write it out conventionally. There you go. So this is necessarily the same as the unordered list, negative 3, positive 8. And when we walk through that, what do we get to? We get to positive 5. So now what happens what does negative 3 mean? Negative 3 means move 3 steps to the left. Or negative x means move x steps to the left. Okay? This part here, to the left or to the right, that is a unit. Fundamentally, that's what that is. So you have a scalar magnitude plus a dimension, like some reference to the dimension that is occurring here. That's what's happening, right? So when you're looking at something and it looks like you have an addition operation, that's not what's occurring. When you're looking at something and it looks like you have a subtraction operation, that's not what's occurring. And you can actually get PEMDAS from this, right? Or at least part of PEMDAS, right? So PEMDAS is what? Parentheses, exponents, multiplication, division, addition, subtraction, right? That's a pain in the ass to write out. Which is why it's written out as PEMDAS. Okay. Well, what's happening here? Why do you do addition and subtraction last? Also, why are they paired together? Why do you do multiplication and division after exponents? And why are they paired together? Well, addition and subtraction are not operations. Addition and subtraction is what you get when all you have left is a list of coherent elements. So once you've worked it down to a point where you have a list of coherent elements, then you can just walk through that list, right? So you say you've got like, I don't know, 13 times 4 plus 7 minus 12 divided by 3 plus 1, right? Just random ass shit, right? So if we do this by PEMDAS, we're gonna have to do the 3 plus 1 first, which is stupid, but we're gonna have to do the 3 plus 1 first, right? So it just becomes all of this, nothing changes here, and 3 plus 1 is 4, right? But you might notice that we could have done this first. There's actually no reason not to do that first, because this is a term. It's isolated from everything else by additions and subtractions. Or, if we note it correctly, right, so there it is as it originally is. Now, we see that you can actually just handle each term individually, independent of any other, and PEMDAS doesn't actually apply, at least not fully, right? So we can do 13 times 4, right? We can do, now we can do this after that, and there's no problem. And then we can do this after that. And now, does it matter what order we do any of this in? No. So we could just change this to this. And now we can just do this, and there you go. That's your result. Right? But when we look at it this way, you can see why. Why PEMDAS is recommended, and also why it's not always necessary to follow it. The way that is conventionally taught is just fucking dogma that you follow, and nobody fully understands why. Even if you mostly understand why, you probably, like, your teachers aren't telling you correctly what's happening. They're giving you some other crazy bullshit, right? So this is like this. If we notated things this way, like what I'm suggesting, shit becomes way clearer. And also, it becomes impossible to end up with, like, the false claim that 1 is the unique successor to 0. Because how would you get that, right? So from Peano's axioms, you get definitions where, like, 0 plus 1 gives you 1. Sure, right? Now, and right, 0 has no successor, or nothing has a nothing. No number exists whose successor is 0. There you go. Fuck. Right. The way he's setting it up, it's just fundamentally wrong, because he's not making 0. He's not recognizing any of the special features of 0. 0 is the unique intersection of every possible dimension at once. So it has all of the dimensionality. It's commensurate with anything, right? Whereas, like, say we have something like this, like, we have a list like this. Right? What can that give you? $11 animals? Yeah, that's fine. Right? It depends what dimension we're operating in. Do dogs, cats, and parrots, do they exist in one dimension? Are we abstracting them down to operate in one dimension, like animals? Yeah? Or pets? Yeah, that works. right? But notice in that dimension, dog, cat, and parrot aren't ordered. There is no sequence to them. Cat is not the successor to dog, right? So what's occurring here is what you really have is you have the numbers, which are things like 1, 7, 2, 13, 3, 4, 198, 6, 5, right? There isn't necessarily an order to that. And you might notice 0 isn't properly in there. 0 isn't really a number, contrary to I think what I've previously said. I've come to a conclusion that 0 isn't really a number. 0 is far more special than that. Right. Fundamentally, these things are just sort of groupings of this. Sort of. But there isn't a direction to that. This, to make this true, we actually have to convert the whole thing. So this is what we write normally, right? Okay, and I'm claiming that that's false. This is what we write normally, but we need to turn that into something else, right? So 0, there's a positive 1, and that yields a positive 1. Well, what does positive 1 mean, right? Recall up here, positive 1 means we move one step to the right. What does 0 mean? Define your current position. So, what is all that is actually happening here? Well, here. Yeah, there's a little more to this. It defines your sort of your current position or your reference position in an infinite dimensional space. So, to move one step to the right, you have to start at 0 anyway, so nothing happened here. All we're saying is that this thing is identical to itself. Because 0 isn't a number. Also, positive 1 isn't a number. Positive 1 is a vector already, because we're, right? So this is not, this is the problem with Peano's arithmetic, and descendants like Pressburger arithmetic. We're not working with numbers, as you claim you are. You're working with vectors and 0, which is very special. It's not really either, because it doesn't have a number component, specifically. It very specifically doesn't have a number component. And it also does not have a unit depth. It doesn't have a unit specification. It is completely despecified for unit, which means it simultaneously operates exactly the same way in every possible dimension that exists, that can exist, that might exist, right? The number of elephants, the number of SpongeBob characters, the number of jackets, right? The number of shit that hasn't been invented yet, the number of shit that's dead, like whatever the fuck. 0 is the same thing everywhere, all at once. And there's some seeming paradoxes that can arise from this, but I'll touch on that in another video. But this is the fundamental problem. When you say that 1 plus 1 is 2, it isn't. It isn't. What do you mean by 1? If you're trying to say that the number 1 plus the number 1 yields the number 2, that's fucking nonsense, because addition is not an operation, for one thing. So the only way to get 1 plus 1 to mean anything is for that 1 to not be a number 1. It has to be a vector positive 1. So now you're not adding numbers, because you can't. And the other problem is, you don't have full unit specifications on this, because what happens is, what do I have one of? What do I have positive one of? In the real world, even a positive one vector can't be added to a positive one vector. It has to be positive one something. Right? It's still, like, that's still not a complete unit specification. Right? It's got to be like positive one dog, or positive 1 kilometer, something like that. So you still, even doing it this way, where you're not ending up with weird paradoxes, right? So you've got, so let's say we change this to the list of positive 1 and positive 1, yielding a movement to positive 2. Okay, when we walk through the list of positive 1, we get positive 2. This requires that this thing over here, this unit on everything else, be identical. If this is something other than that, then this doesn't work. Right? So there is detail here, even at this level, even here, where I've already corrected it significantly. It's still not complete. This still isn't true. Positive 1, a list of positive 1 and positive 1 does not necessarily bring you to positive 2. Because if this is positive 1x, and this is positive 1r, well, we can't actually simplify that. This doesn't give us positive 2 of anything. What it gives us is the list that we started with. That's as far as we can simplify it to. Right? And things like fraction addition, basic algebra, managing units when you're doing engineering or physics or whatever the fuck, they all require awareness of this. So it's amazing to me, because we know this. It's amazing to me that that knowledge somehow gets completely denied when we're teaching mathematics to young children. We teach them lies, and then we wonder why, when they grow up, they struggle to understand these things. And we hit it with, oh, in the 50s and 60s, we hit it with new math. Oh, we got to deal with this. And now we're hitting it with, oh, we got to promote STEM. No, how about you just teach it fucking correctly? How about you do that? Did you ever try not being stupid? God damn it.